The Pythagorean Theorem. In this video, we are going to prove the Pythagorean Theorem using some simple geometric arguments. The Pythagorean Theorem states that if we have a right triangle with legs of length a and b and hypotenuse of length c, then a squared plus b squared equals c squared. To start, let's take a right triangle with legs a and b and hypotenuse c. We don't have much to go on, so let's just use what we have. Let's take this triangle and duplicate it a few times and arrange them like the following. We are starting to get something that we can actually work with. Removing the inside lines, we actually get a square. Now, we have some information that we can gather from the square, such as area, but it won't be too helpful for us right now. Let's actually look at the inside of the square we just made. What I would really like is if I could break the square down into the following parts. These four triangles and this shape formed by our C lengths. And then calculate the area of our square in the following way. However, we don't know for certain that the shape formed by the C's is a square. It certainly looks like a square, but pictures can be misleading, so we really need to show that this is in fact a square. If we can show that this is a square, then we'll have everything we need to prove this theorem. Let's zoom in on all the edges of where our square and our triangles intersect. Since our triangle is a right triangle, we know that the sum of the interior angles is 180 degrees, and we know that theta 1 plus theta 2 plus 90 equals 180, which means that theta 1 plus theta 2 equals 90. Since all the angles of all our shapes lie on a line, that means that the sum of all the angles adds up to 180. This means that theta 1 plus theta 2 plus theta 3 equals 180 degrees. Since theta 1 and theta 2 lie in our triangle, and we know that theta 1 plus theta 2 is 90 degrees, that means that theta 3 has to be 90 degrees. We can use this argument for all interior angles of our C-sided polygon. Thus, we can conclude that the C-sided polygon is in fact a square. We can now calculate the area of the square in two ways. One, we can take the length times the height of our square, which is a plus b, and get a plus b squared. Or we can break it down into these components, our four right triangles and a square formed by our side length c, and calculate the area like that. Setting these two equal to each other, we can cancel out like terms, and we get that a squared plus b squared equals c squared.